Good morning, guys. Alright, I reached out to Sage, but he's not responding, so he may be busy with something else. And a whole bunch of folks are actually out in India right now working on Red Hat Ceph Storage 3.0 planning. So we have a little bit of a smaller crowd this week, but maybe we can just get started here. So let's see. The big news in terms of pull requests this week is Sage submitted a PR for his new encode decode scheme that's based on Alan, Verada, and Sam's work. So if you haven't already taken a look at that, it's worth looking at. It's pretty complex. Maybe others find it not quite as complex as I do, but it's something that you'll probably want to at least spend a little bit of time looking through to understand. The good news is that it seems to be at least as good as what we had before, and I think we'll have a lot of potential to be better. We're still kind of going through and figuring out how it should be integrated into Blue Store and whether or not there are things that we can do to kind of use some of the advantages that it provides in better ways, specifically kind of how to do estimation in a way that lets us avoid as much buffer append behavior as possible. So yeah, just lots of stuff on that. We'll probably be spending a lot of time this week continuing to look into that. Otherwise, there's a couple other things here. It looks like the Zipkin tracing work, a new pull request was made for that. It's basically just based on the existing stuff that was already there. Some more work on removing unneeded searches of the maps in the OSD. Let's see. The Sage's sharded extent map PR got merged last week, so that's in, which is really good. That has improved small random write performance with Blue Store pretty dramatically. So that's definitely worth looking at. Actually, right now in master, at least in the tests I've been doing, we're faster than file store for small random writes, at least in 5-minute tests. I'm not totally sure on longer running tests if that holds true, but the good news is that it looks like we're starting to on NVMe, which is kind of where we were deficient, we're maybe now starting to surpass file store, which is great.
Any idea how much faster?
At least in the short tests, we're looking it looks like we're probably somewhere around 20 to 25%. Although in those tests as well, the performance at the beginning of the test is quite a bit better than at the end of the test. So it may be that over a longer period of time, it's not.
Yeah, Mark, it's coming down there as well. So I'm not able to run more than 30 minutes, but starting from around, for my 16 OSD cases, starting from around 45K mark and coming down to around 25K. So that means
okay.
Around, so considering replication, it will be around 3K per OSD. It's coming down, and then it started swapping memory. So hopefully it will stay there. Earlier cases also it was starting like from 40K, it's coming down to around 15K over the period of 10 hours. So hopefully that will get better with this.
Yeah. So
I mean, that suggests to me that the sharding that the shards may be too large.
Could be.
Yeah, I'm yet to track down around like what is the amount of owner size. It's because of the owner size getting lower. So it still to analyze that what is the size of the owner. In the beginning it is around 400 bytes, but over time how it grows, I see.
So right, one of the things
I mean, the only thing you should see different about the beginning versus the end of the run is that you're switching from a non-sharded to a sharded fetch, so 2 database accesses versus 1. but the write paths should, not be terribly different. Especially, and if you are seeing that, that suggests to me that maybe the shards themselves are still too large.
Alan, one thing that I haven't followed up on that I just saw late last night, was that the amount of space being used is increasing as random writes are done to pre-existing objects. I'm wondering if we're filling up RocksDB with stuff and it's slowing down.
So if space is increasing, that's actually not terribly surprising. I don't think RocksDB does path compression on the keys, and you're adding a lot more keys than you are data. So it wouldn't surprise me to see the RocksDB space, go up significantly. Even by integer factors wouldn't surprise me at all. But it should level out, and it shouldn't be awful. And it's also possible that we're leaking something into RocksDB that's not getting deleted.
That's what I'm wondering, because it's about 8 gigabytes over a 5-minute small 4K random write test.
Yeah, but that should be fairly easy to figure out. I mean, the keys for the O node should be pretty straightforward.
Yeah. So one of the things I think I need to do is sit down and actually rip out what's in RocksDB after one of these tests and just look at what's there and what's taking up space. Because presumably, if we've got tons and tons of stuff in there, I don't know, I would suspect that maybe RocksDB itself is slowing down.
What would be interesting would be just a simple program that just reads RocksDB front to end and does even just a simple histogram across the different key spaces, counts up the keys and the average sizes and just some stupid stats across those. It would be a fairly simple program to write, and it would be really useful in this environment.
Yes, I agree. I think that would be very useful.
Yeah, even on a running system, if you just do a read-only fetch from RocksDB of what's out there, it probably would be okay.
Yeah. So another thing I want to do here as well that I haven't tried in a while is actually using the memdb store backend to see if we can get some output from that. One of the things that I think go ahead.
Actually, I'd like to see that code stuck into BlueStore so that it could be fired off on a running system. You just have a runtime command, you run it, and it forks off a thread and does the whole thing, and you get the answer. And if it takes 15 minutes, so be it.
You're talking about memdb store?
No, RocksDB.
No, the RocksDB
code,
thing. Yeah.
Not even Rocks. I mean, just code that takes the running BlueStore KV store and runs and just does an index on the whole thing and analyzes it. That should be. Sure. I mean, it's even easier to write that command as something built into the code base, and that would be, I think, really useful.
Yeah, I think the other part of that would be really useful is for it to actually go through and look for things that it doesn't expect to be there, right? Like you have labeled what you do expect to be there, and then anything else, we can get statistics on that.
Yeah,
like
agreed.
WoW writes or whatever.
Yeah, I mean, eventually that starts to get more sophisticated, and you end up with FS check.
Yeah, okay.
I mean, you're on a slippery slope. Okay, yeah. I'd rather, with respect to that, I'd rather just put the energy into the FS check code and make sure that does what you're describing. But I think that's different than something that's a tool that we can use that that will give us stats about what's going on. I think during the stage that we're in, learning about that would be really helpful.
Yeah. So, Alan, another point that we touched on the mailing list last night was what's going on in the bitmap allocator. I don't know that code at all, but you had mentioned that you were wondering about the size of the maps, if I recall. Is that correct?
That's not ringing a bell.
Okay. this
I mean,
red-black tree traversal time.
Yeah, I know that we had seen some performance degradations earlier on, and I think we tracked a lot of that down to debug code doing extra checking, which is, I think a good thing. But fundamentally, if Somnath had done some work measuring the performance of bitmap allocator versus stupid allocator, and but my comment is that by design, bitmap allocator should have the same big O performance as stupid allocator. So I'd be really surprised if you're seeing significant CPU differences between the two. I think we tracked that down to the debug, and then I think we've gone quiet on that part of it in the interim.
No, Alan. So recently, actually, Ramesh fixed that. Those debug assert is now compiled out. So
as of 2 hours ago.
Right. I understand that. I understand that, but that doesn't necessarily prove that that's the sole source of the delta that Somnath was seeing. We just know that was the major contributor to what he was seeing. As to, I mean, so at this point, the experiment, to compare the two, might prove to be worthwhile. It might not, and if it does, again, that might suggest that there's something about the implementation that's worth going and looking at.
Here we go,
I'd be
Alan.
surprised.
I found some of the things I was interested in here. So one was the child check-in lock in bitmap area leaf, and then another was bitmap zone lock excel try. Exclusive try.
So you're seeing lock contention. Yeah, okay.
Potentially, or at least a lot of CPU time spent on these. Not necessarily. I don't know what real time is spent on them, but it looks like there's actually some CPU time spent on it.
I'm wondering. Okay, do you have the debug code in?
Yeah.
Yeah, well, then you're going to get a lot of contention. Again,
I don't think any measurements taken before that thing was merged 2 hours ago is not useful.
Yeah. I think if you rerun that, you're going to see a very different profile, and things like that probably aren't going to matter now. I'd be stunned if there's a lot of collisions on the internal locking and bitmap allocator. It just can't be that big a percentage of what's going on unless there's something seriously messed up in the code.
Okay. Well, that's good or bad news.
Pretty good.
Okay, so that was 2 hours ago, you said, Sage?
Yeah, I just merged it this morning.
Fantastic. I'll go through and retest that.
I'd love to see where we are with all of these latest stuff. Any graphs that we could produce would be great.
I started going through a full test of basically a whole bunch of different I/O sizes and different kinds of I/O, and we crashed about halfway through with whatever I posted to the mailing list on Somnath's in response to Somnath's one. But at least with 4K random. Oh, go ahead.
No, I was going to say I've got a number of internal reviews that would be good to show better numbers at.
Well, with Sage's sharded his code that he had, the extent map. Sorry, I can't talk. With that was huge. That basically, like, at least in the tests I was doing where we were CPU limited, that was like double the performance at least. And then throw this on, and we're doing a little bit better yet, at least for 4K random writes. So
right, and still the encode decode framework itself hasn't been fully utilized. I suspect there's performance in other parts of the code base we're going to pick up because of that.
Me too.
Yeah. Anyways, it would be nice if we could get this thing to run long enough, in the next couple of days, where we could repeat the kind of graphs that you had. It would be nice to see where we are and take another snapshot of where the CPU time is going, because I suspect it's the profile will look radically different now with all of these different things that we've done to it.
Yeah, I'll actually, as soon as this meeting is over, I'll start on another set of tests. First, looking at 4K random rates, and then after that, we'll go through and try a full sweep. But I imagine we'll have some bugs to work out here before we get anything really good. It's usually the way it goes.
Yeah, also this sort of large memory consumption, I speculated that we may be losing performance because of that too.
Yeah, very well could be. Beyond just the
so one thing is that if the performance degradation over time is happening because of total amount of data is being written to RocksDB, so I think it will be still there. But if it is on the PAR IO cases, if that is actually, I saw that PAR actually almost similar initially, but I had to still check the long run what is the effect. But if PAR IO case actually is the one that's degrading the performance, I think that will be benefiting with this thing.
Yeah, you should see it stabilize sooner because it's really bimodal. In the case you've got, you're converting from everything inside of one extent to basically an extent per 4K chunk. But I think you'll be dominated by the extra dB access on the read side for a sharded extent map, and for 2 writes on the right side. And you get to that state pretty quickly. It shouldn't take too long or too many overwrites of an O node before he shards it. And once he shards it, I don't think additional sharding is going to make a significant difference in the amount of work that you're doing. So the degradation that you see should plateau out sooner in time than it does with the current code, and presumably at a much higher level too.
Yep, that will be great. We'll see.
Hey Sage, I had a question for you here that's probably going to be really annoying. I'm seeing in code sum that you're doing a var int encode of 4 uint32Ts right in a row. Is that the blob ID, the logical offset length, and blob offset?
That is the estimate. That's calculating the upper bound on how much space. That's not actually encoding. That's the bound.
No. Sorry. Yes, but we're doing that for a reason, right? Because we're potentially going to encode up to four of those.
We might encode up to 4, but you'll notice in the block where it actually encodes them, whether it encodes each one is conditional based on certain common patterns, whether it's contiguous or has 0 offset, 0 length, etc. So most of the time we encode none of them, or only one. Usually we only encode the blob ID, but in other cases we'll encode others.
So in a uint32T group var encode, if you didn't do a 24-bit value because you're only doing 8, 16, or 32, you could use that extra bit as an indicator in the prefix whether or not it exists, right? So you could actually encode 4 with a conditional of whether or not it's there to not actually encode anything beyond that.
Yep. I think that the first step is to get meaningful profile. I'm looking at a profile here and I can't see any of this show up on a profile.
Yeah, neither did I actually. So that's probably that.
I do see encode sum taking 1.5% of the CPU time.
That's less than on mine, but okay.
But I can't tell. I'm trying to get perf report to actually show me the callees now instead of the callers, and it's not doing it. It's only showing me callers, which is sort of irritating. I don't know what I'm doing wrong, but
there's a bug in certain kernels that makes that not work. That flag not work.
This is on perf report though.
Yes.
Perf report would show.
It doesn't work because there's a bug in perf report in certain kernel versions.
Oh, lovely. Okay.
Yeah. Which one are you on? What kernel?
This is Fedora 23, I think.
Kernel?
This is Fedora 23. Kernel is 4.4.8.
Okay, that's like one of the aftermarket ones, not the stock one.
This is the stock Fedora kernel.
Oh, that's right, Fedora. Sorry, I was thinking
Fedora
CentOS.
23.
Okay.
Yeah.
I have absolutely no idea. You'll have to find out. You'll have to look and see
Yeah.
this. Yeah.
Yeah.
I have no idea.
Yeah. So I guess that's good news. What I really want to see is the profile of the function, the cumulative time spent in a function sorted by that function, so I can go look at all the, like I filter out just the buffer functions. The highest buffer function is append, buffer list append, and that only has 1.17%. And most of that, of the callers, it's like the highest is 0.17%, and it's OSTree request encode. Like it's all little tiny stuff.
The thing that I was seeing is even though it looks small, it was actually having an effect, at least before in the old code.
Yeah,
like
but it's all the old code has a million different things that encode, and so cumulative, if you add all of them up, it's 1.17%, but none of them are particularly big. I'm not seeing. There's only one STL map that's coming up, and that's the buffer. What is it? It's a map of buffers, I think. I don't know. I wasn't seeing anything.
Okay.
I'm gonna run this for longer. I just ran it for 60 seconds.
Okay.
Let's see if that makes a difference.
Are you doing your single op tests where you're just looking at latency, or are you actually?
No, I switched to 32. I have 32. Queued up to 32. It's getting about 5,000 IOPS off of a single OSD.
Okay.
It still has some debugging on. I do see like 5% of the time spent in the op tracker.
Yeah, so that's the amount of IO you're also getting, 5,000 per OSD. In my case, with 16 OSD case, it's probably fast, probably 2-3 minutes, and probably run longer, it will come down.
Mm-hmm.
Sage, are you anywhere close to CPU limited yet?
Let's see. It's using 300% CPU. I mean, I don't know what. I mean, if I throw more threads at it, it doesn't go any faster. So, put an NVMe card. I think it's CPU limited.
Mm-hmm.
But this box says, a zillion cores. So, I don't know.
So one thing that I was doing to try to kind of exercise the CPUs a little bit more is I actually broke the NVMe up into multiple OSDs on it. You might try that and see if that.
Shouldn't that increase contention on the NVMe?
Well, the NVMe is fast enough that it just basically makes the CPU max out because we're doing enough work that we're CPU bound rather than NVMe bound.
Okay.
It means we don't have enough parallelism in the OSD yet.
Yeah, probably. But we've known that for a long time. I think Intel showed that like 2 years ago or something, and we're still probably there.
Yeah, well, we've been struggling against that for years.
Yeah.
And improving it.
Oh, no, it's up to 7,500 IOPS when I turned off the op tracker.
That's good news.
Okay, well, I'll keep playing with this. So this is unrelated to performance, but the leak checker or the leak fix branch is passing my tests. Anybody want to take a quick look before I merge it, or should I just merge it?
Merge it.
Yeah, just merge it. I'll test it along with other stuff.
Oh, yeah, you already reviewed it. I was thinking. Okay, cool.
In your test, did you see any kind of time spent in bitmap allocator locking stuff?
I haven't. Did see bitmap allocator coming up. I just blew away my thing. I'm running a new profile, so I have to look again. But again, I didn't have the branch that removes all the debug stuff yet, so I got to rebase.
Yeah, neither do I. I was just curious if you were seeing that too.
I did see it.
Okay.
It doesn't really mean anything.
No.
Okay.
All right. So for everyone else that's listening, the gist of all of this is that we're going through and trying to make all this work as best we can. What was it?
In progress.
Yes. And it is even now faster than file store, at least in short running tests. So definitely good progress.
I think you need to be careful if you're not getting a compaction cycle of RocksDB into your short running test, then your comments about it being faster might turn out not to be true over the long haul.
It looks like we're hitting multiple compaction cycles, at least from the stuff I've looked at.
Okay, that's good.
Yeah. So it's somewhat integrated, but clearly there's something going on over time. So let's see. What else? Oh, the only thing else I had in here was another person on the mailing list was talking about slow RGW performance once they get up to millions, like 18 million objects or something, and I kind of tried to write out a response as to why that happens and just kind of a big general overview of what we know. So if anyone's interested in that, go out and take a look. But I think probably the answer really is Blue Store, and we try to reevaluate it once we've got this stuff all kind of in a sane state. At least that's my take on it.
Mm-hmm.
All right. Anyone else have anything that they want to talk about this week? All right, then we have a half an hour extra to get back to work and get this stuff going. So have a good week, everyone.
Guys.